Hi everybody, let's talk about statistics. There are three parts to 5A, which is the basics of statistics and how you set up a study, and then we'll kind of go from there. But the first one is we need to know what statistics are. It is a science of collecting, organizing, and interpreting data. It is a science all unto itself. It is a part of math, but you can get a separate degree in statistics. You can go on and use statistics and probability to become an actuary. The statistics themselves are the data, the numbers, the other pieces of information that describe or summarize something. So you're going to collect and organize data and then interpret that data. Okay. Statistical studies infer reasonable values on a population based on a sample. If you want to do a study of all Americans, there is no way that you can get responses from all Americans. So you want to create a sample. And so once you've created that sample, you can infer what a reasonable value would be for the population. You take that statistic and apply it to the general population. Okay, so we know what a statistical study is, and here's how we do this, and it's presented to you both in a flow chart and in a statement here. So the first thing that you are going to want to do is state the goal. You have to have a goal, which is, what do you want to know? So you identify your goal. What is it that you want to know? Within that goal, that will tell you what the population is. That is who you want to know the information from. Okay, say I want to know how much chocolate people eat in the United States. So that's what I want to know. The population who I want to know it from is people in the United States. So the population is going to be within your goal. Okay. From there, we are going to choose a sample which is from the population, and you may want to make a note that a sample is a subset of the population. And that is who we're actually going to collect data from. If I want to know about chocolate and everybody in the United States, of course I can't poll everybody in the United States. So I'm going to have to somehow get a sample. Okay. Once we found that sample and we have asked them the question, then we are going to collect the data and summarize it by finding a sample statistic. Okay. That goes with the sample. Okay, so let's say that we found that 85% of the sample like chocolate. Okay. All right. Then this is where we go back to inferring a reasonable value. If we have a population and we've chosen a subset of that in some fashion, a sample, then we can say, okay, well, based on this sample, this is what's going on for the entire population. And so this takes what we did in the sample and refers it back to the entire population. Okay, well, so we found that from our sample, 85% of the sample like chocolate, so we can infer from that that 85% of people in the United States like chocolate. Okay. And then finally, we draw conclusions. What did we learn and how it addresses your goals? Let's look at the goal, relook at the goal of the study and see if it actually supported what you thought, didn't support what you wanted. You have to think about this one a little bit and find out, well, what can I infer from this? And we'll talk about that as we go along. Now, I reprinted this because I added a little bit of stuff from it from class, which is how to think about the conclusion, because I know that that was a little bit confounding to some students last night. Okay, so a presidential candidate wishes to know his approval rating among American voters in, and I forgot to correct the typo, in the 18 to 24 bracket. He hires a polling company who contacts 2,096 registered voters ages 18 to 24 to ask their opinion. The polling company finds 39% of the sample approved of the candidate. Okay, well, here we go. All right, so what does he want to know? The goal of the study. He wishes to know his approval rating among American voters in the 18 to 24 age bracket. Okay. So we need to know the approval rating of the candidate among American, and I'm going to abbreviate this, voters 18 to 24. Okay. From this goal is where I am going to get the population. This is who do I want to know stuff about? Well, American voters age 18 to 24 is within my goal. So this is American voters age 18 to 24. Okay, so he can't poll every American voter age 18 to 24. So now they're going to choose a sample. Okay, so he hires a polling company who contacts 2,096 registered voters age 18 to 24. So that is our sample. Of all American voters age 18 to 24, they selected 2,096 registered voters age 18 to 24. So they're only going to have data on the sample, so the sample statistic comes from there. And this is, what did they find? What did they find from the sample? They found that 39% of the sample approved of the candidate. So the sample statistic is 39% approval. Okay, so now we need to take this sample statistic and apply it to the population. So we can say that the 39% approval rating from the 2,096 registered voters, we can infer that that applies to all voters. So we can infer that the approval rating is 39% among American voters 18 to 24. We found that there was a 39% approval rating for the sample, and we can infer then the 39% approval rating applies to all American voters. Okay, now the drawing conclusions, that's going to be a little bit different. Again, drawing conclusions is going to be based on what they want to know. Now, did he just want to know, this one, a goal on this, the candidate, he just wanted to know. But what did he learn from this? Well, he learned that his approval rating was 39%. So again, drawing conclusions, he learned that his approval rating was 39% among American voters 18 to 24. But the conclusions that, what did he learn from this? He needs to appeal to more voters in this group. He also may have learned, maybe he thought he was polling at 20%. Okay, he may have, the conclusion may have been, well, I'm appealing to more than I thought. So we would need to know a little bit more about the why before we go with anything else. Okay. Sometimes this will be more clear, sometimes it will be less clear, depending upon the actual study. Okay, the next one, a car manufacturer randomly selects some dealerships in the Midwest to gather data on car sales and weather patterns. They wish to know, okay, so they wish to know, this tells us what our goal is. They wish to know if dealerships in severe weather areas have higher selling rates following significant weather events. Okay. So they want to know if dealerships, and we're just going to have to, there are no shortcuts on this, you're just going to have to write it out. If dealerships in severe weather areas, and see I left you more space on this one, have higher selling rates following significant weather events. Okay, so we've got our goal. Within our goal is going to be the population, the who. And it says these are dealerships in severe weather areas. So within our goal, we found that who they want to know stuff about is dealerships in severe weather areas. Okay. All right. They can't look at all dealerships in severe weather areas, so they're going to have to pick a sample. Okay, so the sample that they pick, let me see. Okay, so they select some dealerships in the Midwest. So their sample is going to be some dealerships in the Midwest. And they gather data from those. Okay, so it says that the dealerships in the sample, this tells you what our sample statistic is going to be, what they found. In the sample sold an average of 12 more cars per week following a significant weather event. So the sample statistic is sold 12 more cars per week. Okay, so now we're going to have to find our population parameter. What that means is we're going to take this sample statistic, where instead of taking it out of the sample, we are going to apply it to the population. So we can say that dealerships in severe weather areas sold 12 more cars per week following severe weather events. Okay. Okay. So let's see, drawing conclusions now. Well, what they wanted to know if they have higher selling rates. Okay. So the answer to this is the sales rates are higher after significant weather events. That's what they wanted to know. Okay, let's do a couple more. Alrighty. Some people believe that wearing copper bracelets can help decrease the symptoms of arthritis in hands for people with arthritis of the hands. Okay, so let's see what we can do with this one then. A doctor decides to test his theory by randomly assigning 279 patients with arthritis of the hands to one of three groups. 100 patients to wear a copper bracelet for 3 months, 100 wear a nickel bracelet for 3 months, and the remaining 79 wear no bracelet for 3 months. After 3 months, she finds that the average pain rating in the first group has decreased by 1.5 points on a scale of 1 to 10, as opposed to a decrease of 0.3 points in the second group and no change in the third group. Oops, and I'm sorry, I forgot to scoot that up. Okay, so let's see what the goal of the study is. Okay. The goal of the study is determine if wearing copper bracelets can help decrease the symptoms of arthritis in the hands of people with arthritis of the hands. Okay, that seems really redundant, but you would have to have arthritis of the hands for the symptoms to go down. Okay, so determine if wearing copper bracelets helps decrease symptoms of arthritis in the hands of people with arthritis of the hands. Okay. Okay, within this goal is the population. What is the population? Well, the population is all people with arthritis of the hands. People with arthritis of the hands. Okay. Let's look at our sample. Our sample, he's testing his theory on 279 patients with arthritis of the hands. So that's 279 patients with arthritis. Of the hands. And the sample statistic. Now there are some things that they broke them into 3 groups. Okay. 100 patients wore the copper bracelet, 100 wore the nickel, and the remaining wore no bracelet. Okay, so the sample statistic is the copper bracelet decreased 1.5 points, nickel decreased 0.3 points, and no bracelet no change. Okay. All right, so the population parameter. The population parameter is, and this is one where we can actually do this a little bit differently. What did we find here? We're going to have to make an inference about this into the population parameter. The copper decreased quite a bit on a scale of 1 to 10. The nickel had very little impact, and no bracelet, there was no change. So the population parameter would be wearing a copper bracelet decrease pain by 1.5 points in the population, which is all people with arthritis of the hands. Okay. Okay. So the overall conclusion on this, again, is kind of the same thing as the population. But it didn't. There are other symptoms to arthritis, and so you could say wearing copper bracelets does decrease symptoms in people with arthritis. So again, the conclusion and the parameter, they can be very, very similar, but sometimes not. Okay, I thought I could do this all on one video, but I think since we've got 2 more examples, I think I'll switch. Okie dokie.